Very good morning, students. Welcome back, second year physics. See, actually, we are discussing about a new chapter that is related to the field and charge. See, in the previous class only we discussed about a properties of charges and as well as the charge unit and charge dimensional formula and related to the quantization of charge and conservation of a charge. See, the conservation of charge is very important. Charge can either be created nor be destroyed, but the total charge of the system remains constant. That we can say conservation. And quantization in the sense is the total charge of the system, which is equal to the integral multiple of electrons. That we can say, if a system contains some number of electrons, that n is nothing but represented as number of electrons. E is the charge of electron, 1.6 into 10 power minus 19 coulombs. That we should remember, right? And coming to the next one. So this is the previous class what we discussed. Let us, I would like to tell you another one, that is additive property. Sir, what is mean by additive? Additive in the sense is add. If the system is contains a number of charges, the charges are located at a different places. Suppose I will tell you like this: if one system contains, there are charges which are located at a different places, Q1, Q2, Q3, Q4 and Q5. Like this, the system is contains a 5 number charges. Additive in the sense is add all charges which are located at a different places. That individual charges are there, no? Then you say the algebraic sum of all charges. The sum of all charges gives a total charge of the system. So you say Q is equal to Q1 plus, Q2 plus, Q3 plus and Q4 plus. There are 5 charges are there, no? This we can say additive. Additive in the sense add all charge. Sum of all the charge. Sum of all individual charges which are located at a different place. Give the total charge of the system is nothing but we can call additive property. Additive property. Q is equal to Q1 plus, Q2 plus, Q3 plus, Q4 plus, Q5, because the system contains a 5 number charge. So the odd in the sense additive. So this is the property we can call as the additive property. Now let us, another one is there that we can say about a electrification. Sir, what is electrification? See, this is the process actually. You say electrification. Sir, what is the electrification? See, the electrification is nothing but the process of giving charge or removing charge, or we can also call the process of adding the charges to the system or removing the charges from the system is nothing but we can call as the electrification. The process of giving charges or removing the charges from the body is nothing but we can call as the electrification. So in this process, by adding or by removing the charges, so in this process the body can be charged. See, remember, nothing but what? When we are giving the charges to the body, therefore the body becomes the excess of charges. So excess of charges is nothing but the body becomes a negatively charged body, because if there is a more number electrons, excess of electrons are there. So when there is an excess, we can call as a negatively charged body. Suppose we are removing from the body, the charges are removed from the body. When removing is nothing but we can call as a positively charged, because there it is to be deficiency of electrons, deficiency of charges. That we can call the process of adding or removing the charges from the body. Then we can say electrification. The method we can call as the electrification, and in this method the body can be charged. This is the method of electrification, and in this method the body can be charged. No, there are 3 methods of electrifications are there. That is the first method related to the electrification. There is a first method by friction. See, friction the body can be charged, and by conduction. So by conduction also body can be charged, and by induction, of course by induction also the body can be charged. Sir, what are these all process? By the friction is nothing but a very simple explanation I will tell you. So by the friction the body can be charged. Sir, how the body can be charged by the friction? Suppose you take a pen, or you take a scale or a pen, or you take a rod. So that this all bodies are neutral bodies. Nothing but what? The both positives and negative charges are equally distributed. Neutral in the sense. that we can call as the both positive and negative charges are equally distributed. If the body it is distributed equally, we can call as the neutral body. You take a pen, so the pen or a scale, say that it is nothing but a neutral. See, if you rub on the silk cloth or you rub on head, suppose you rub on head, so before rubbing, once you check the body it is neutral, it does not attract any dust particles. You take a dust or you take a small papers, small papers, if you take a small papers and you tear it, and after tearing I will show you one explanation, and I will give you one example related to this. Okay. Yeah, I will show you one explanation related to this by the friction, how the body can be charged. See, you take a small papers, right? See, you tear it like small papers, you take very small. See, after like this doing, you keep in your hand or you keep in your on the table, on the book, wherever it is. So you take a pen, if you put on if you put very close to this, it does not attract. The papers are not attracting because it is a neutral body, right? If you rub on your head or the rod you take, the rod is rubbing on the silk clothes, so that when rubbing, due to the friction, the charges are transferred from the pen to our hair or from the scale to our hair. Or if you are using a rod rubbing on the silk cloth, therefore from the rod some charges are transferred to the silk cloth. Therefore the rod or a pen, it is become a positively charged because there is a deficiency are there. So if you put on the papers, small papers or dust particle, then immediately that attracts. Attracting in the nothing but a what? There is a deficiency of charges are there. See, it is common, we can experience, we can see by using the by conducting the experiment, like you take a small papers, yes, then we'll get the simple experiment it is. So that when rubbing, so when rubbing is nothing but there is a friction. Due to the friction, the charges are transferred from the body to the silk cloth, or the charges are transferred from the pen to our air. Therefore what happens, that air is becoming negatively charged because there it is to be excess of charges, and pen is become a positively charged. So there is a deficiency of charges, so that when it is placed on the dust particles, therefore or on a small papers, it is attracts. This is the experiment, we can say the body can be charged. So by friction the body can be charged, so that by rubbing like this, therefore you take a rod or you take a silk cloth and both will be rubbed. Therefore from the rod the charges are transferred, therefore the silk cloth is become a negatively charged and the rod is become a positively charged. This is the about a by friction the body can be charged. By friction the body can be charged. And coming to the point is conduction. Sir, what is mean by conduction? Very simple explanation I will tell you. By the conduction also body can be charged. How the body can be charged? See, by conduction you take like this. By conduction, right? Conduction in the sense is you take a one uncharged body, that is we can say neutral body, we can also call uncharged or neutral body, and here another one charged body. Suppose you are taking a charged body, it is a charged body which is kept in contact. Suppose if I take a positively charged body, therefore when it is kept in the contact like this, because of the positively charged, therefore in this neutral body, or we can say uncharged in the sense also same, the positive and negatives are equally distributed. Because of the positively charged body kept in contact with the uncharged or a neutral body, because of the influence of a charged body, what will happen? This body becomes a charged, because all negatives will come towards a positively charged body in that neutral body. When positively charged body is kept in contact like this, see, you take a uncharged body, again neutral body, and again you kept in contact with the charged body. Suppose if you take a negatively charged body like this, when it is kept in contact with the negatively charged body to be like this, therefore what happens? That neutral body again, because of the influence of a negatively charged body, this all positive will come towards a negatively charged body. So that neutral body or uncharged body become a charge because of the influence of the charged body which is kept in contact. very simple, which is kept in contact. When the two bodies are kept in contact like this, because of the influence, therefore the body becomes a charged. When positively body contact or when negatively charged body is kept in contact with the uncharged body, because of the influence of a charged body, whichever body, whatever the body, either a positive or a negative, which is kept in contact, because of the influence of this charged body, this neutral or uncharged body becomes charged. Neutral or uncharged body becomes charged because of the influence of a charged body. And here, after when it is kept in contact like this, and here it is to be both the bodies, you remember, both the bodies, like here positive is kept in with the neutral body, negative is kept in with the neutral body. See, because of the conduction, both the bodies acquires the same nature of a charge. Same nature will be what? Suppose here, I don't know which one will get. Same nature in the sense is both the bodies acquires the same charges. Same charges, that neutral body and the charged body, it is acquires the same nature of a charge. That means here both will repel each other. Both will repel each other because the same nature will get, no? So, same nature in the sense, suppose if it is positive, no, it may be become a positive, or it is maybe both the bodies become a negative also. We cannot say. So, that because of the conduction, both the bodies acquires the same nature of a charge. Same nature, and the charges are distributed equally. That means here, I want to tell you one thing. Suppose the charge is equally distributed in the senses after conduction, it is Q1 dash is equal to, you say Q2 dash is equal to Q1 plus Q2 by 2. Both will accuse the same nature, and as well as the charges are equally distributed. Charges are equally distributed. This method is nothing but a conduction. Conduction in the sense is when two bodies are kept in contact. One is the uncharged body and one more is a charged body, which are kept in contact. So, because of the contact, therefore, both the bodies acquire the same nature, and the uncharged body becomes charged because of the influence of the charged body. Because of the influence of the charged body, both the bodies acquire the same nature. That means here both attains the same nature, no? Therefore, the both will be repels. So, by the repulsion we can say that both the bodies acquire the same nature, because like charges always repel. When it is like will get, therefore automatically the bodies will be repelled. And here after conduction you remember that charges are distributed equally. Because of the conduction, the charges are distributed equally. This is the method we can call as a conduction. And you remember here one point I'll tell you one thing. See, by the electrification, we can say by the electrification, in case of a conduction, repulsion is a sure test to identify the charges on the bodies, because if they are repelling is nothing but a what, we can say the bodies are attaining the same nature. If they are tracks, we cannot say which body it is to be having the same charge. So that here by the repulsion only we can conclude that, or we can say that the repulsion is a sure test to identify the nature of the charges, because if they are repelling is nothing but of course we cannot say the bodies are having a positive or negative. We cannot reveal, but we can say that two bodies are having the same nature, either a positive or negative. So that here by the conduction we can say it is the body it is to be charged, because when they are in contact, influence of the charged body, uncharged body becomes a charged. Like we can say like this. And here after conduction, the nature of the body is to be same, and the charges are distributed equally like this. Suppose I will tell you one small question. You take one charged body Q1, another charged body Q2, right? When they are kept in contact, let us you take two spheres which are kept in contact like this. So, when it is kept in contact, initially charges are Q1, Q2, and it is separated like this. Therefore, after conduction, the nature will be the same. Nature will get the same, and as well as the charges are equally distributed, that you say Q1 dash is equal to Q1 plus Q2 by 2 for first body after conduction I am telling, and here Q2 dash is equal to Q1 plus Q2 by 2. This is, we can say, by the conduction both the bodies acquire the same nature, as well as the charges are distributed equally. So, the process which we can call as the conduction. See, by electrification, what I mean here by electrification, the method of electrification is nothing but giving the charge or removing the charge. By the method of giving charge or by method of removing the charges is nothing but a process which we can call electrification. In this electrification, there are three methods: friction, conduction and induction. Friction is over and the conduction we can say like this. And here there is a repulsion is a sure test, everyone remember. Repulsion is a sure test to identify the charges or nature of the charge. So that's what it is for 2 marks question. For 2 marks, see, the repulsion is a sure test. Why? Because we can say when they repel, nothing but what happens? Yes, of course. Here it is to be repulsion in the sense we can say, there it is to be the both the bodies are occurring the same nature. Clear? By conduction we can reveal the charges. Yes, by the conduction we can reveal the charges. So that it is to be like this. Conduction is the method of electrification. And here after conduction what happens? That both the bodies occurs the same nature and as well as the charges are distributed equally. This is the method of conduction. And let us, we'll go for the next one, that is by induction. Sir, what is induction? In this induction in the sense is, induction is nothing but a, conduction is nothing but a both the bodies, you say, which are kept in contact. Now let us, I'll tell you another one, that is about a induction. You take third point, that is about a third one. You say like this. See, induction will be, so this is the third method. See, by the induction in the sense, again you take one neutral body, that is an uncharged body or neutral body, nothing but what, the both positives are negatively equally distributed. And here one more charged body, say it is a charged body, you say. See, induction in the sense is, you take a positive or negative. See, so charged body in the sense is, you remember, when there is a charged body is nothing but a, so charged is nothing but a, that creates a force around the charged body. Suppose you take a pen is a charged body, therefore here the, because of the charge, therefore influence is felt around the charged body, or the force experienced by the charged body around the charged body. So that it is experiences some force around the charged body, and it is a neutral body, no, which is kept in very close to the charged body, not in contact. If it is in contact, is nothing but we can call as a conduction. But now what I am telling, if the uncharged body which is placed very close to the charged body, very close, when it is placed very close to the charged body, therefore what happens? This uncharged body becomes a charge because of the influence of the charged body. Because of the influence of the charged body, this uncharged body becomes a charge. Very simple. What I mean here, say it is a charged body and it is an uncharged body. Therefore, this is the charged node. Therefore, there is a force experiences around the charged body. Little distance, not in meters. Say little force experiences around the charged body. In that field, in that force, if an uncharged body is placed very close, not in contact, look at. So that because of this influence of the field, this uncharged body become a charged. Nothing but what happens? Here it is, this is the positive is there, no? Therefore, in this uncharged body, all negatives will come towards a charged body. There is a gap between the uncharged and the charged body. So there is a gap is nothing but there is some medium is there. The medium, maybe it is a air, maybe is the other medium also we can say. So that because of the influence of this medium, or because of the influence of the charged body, this uncharged body become a charge, because all negatives are towards a positively charged. So that this negative positive will be attracts. That's what here we can say. Here induction does not reveal the charges, because if it is attracts, we cannot say the bodies which is having a negative, which is having a positive. That's what here conduction reveals the charges on the charged body. That's what we can say repulsion is a sure test. Repulsion is because both the bodies are repelled. If repel is nothing but that are having a same nature. If attraction is there, so we cannot say which one is having a charge. Of course, I know positive, I know negative. If in the experiment, if they are giving a two bodies, then identify the charges. We cannot identify. By the induction, we cannot identify. By the conduction, yes, we can identify. So that here, if the between the two bodies, if there is a there is a air is the medium, or if there is a another medium like water, like you say bad conductor between the two conductors, between the two bodies, it may be other like a metal, So there is a medium is there. So that influence of that medium or influence of this charged body, this uncharged body becomes a charge. Suppose the charged body you say Q, and because of the influence of this charged body, this body uncharged body become a charged, no? Because of the induction there is a charge is induced, that is you say Q dash. Q dash charge is induced because before induction there is no charge, because it is an uncharged body. Because of the influence of the charged body, this uncharged body becomes charged, no? Therefore the charge is induced on the uncharged body becomes Q dash. That Q dash is very simple, it is less than Q, very simple. The induced charge is, it is less than the Q, because charged body charge is more, or you say Q greater than Q dash, we can say like this. Q dash is nothing but a induced charge because of the influence of the charged body, and there is a medium is there. So there is one expression is there, I will give you that Q dash is equal to, it is minus Q into 1 minus 1 by K. You remember this expression, again I will tell you the derivation in the next classes, right away it is not required. Sir, Q dash is nothing but a induced charge, Q is nothing but a charged body. What is K? K is nothing but a medium between the two bodies, that we can call as the dielectric constant, we can say. Sir, what is dielectrics? That's what we can say. There is a medium. If air is the medium, or vacuum is the medium, or water is the medium, like metal is the medium, like a bad conductor is the medium. So the K value, you remember, for air or vacuum, suppose if there is a air or vacuum, that we can say 1. Dielectrical constant for air or vacuum, which we can say it is equal to 1. Suppose I want to tell you K water, if there is a between the two bodies, if it is water is there, between the two bodies water is the medium is there, for that value is 81. And suppose I'll tell you bad conductor is there. See, for bad conductor it is 0, and whereas the K value for metal, you take a metal is there between this, then we can say infinite. So these are the induction method. Once again I am telling you, by induction we cannot reveal the charges, but whereas by conduction we can reveal the charges on the charged body. It is very simple, so that the repulsion is a sure test to identify the charges or to reveal the charges on the charged body. So this is method of electrification. There are three methods. One we can say friction, one we can say conduction, one we can say induction. Conduction method, in the friction already over, and it is an induction method. So there is a charge is induces to be like this. Clear? It is about a what? We can say like this. Clear? And coming to the point. See, after this I will tell you another one also. On this basis only, let us we have about a substances. In case of a electrical substances, there are three types of electrical substances are there. One we can say conductor, one we can say bad conductor, one more we can say semiconductor. Sir, what are these? Here you remember, based on the property of electricity, or based on the properties of charge. So that there are three types of substances are there based on the electrification, that is conductor, bad conductor and semiconductor. So what is conductor? Conductor in the sense is the substance which allows the flow of charges. It allows the flow of charges, conductor, because it is very, very important. So if we know the differences between conductor and bad conductor and semiconductor, then we can do better performance in these chapters. Conductor is nothing but in that conductor there are more number of free electrons are available. So because of the number of charges are available, free charges are available, therefore the charges are responsible to allow the other charges to the conductor through the substance, which we can call as the conductor. In that case, that electrons are not bounded with the nucleus. If it is tightly bounded with the nucleus, that free electrons are tightly bounded with the nucleus, then the substance which we can call as the bad conductor. In case of a bad conductor, the substances does not allow the electrons or does not allow the charges. The substance which we can call as the bad conductor. Bad conductor in the sense is the substances does not allow the flow of charges. See that the substance are not allowing in the senses we can call what? That free electrons are tightly bounded with the nucleus. So that the substances does not allow, that we can call bad conductor. See, remember, bad conductor and as well as the conductor, and one more is the semiconductor. Here, coming to the next one, semiconductor. So what is semiconductor? Semiconductor is nothing but the substances which allows partially flow of charges. That means here, at an high temperature, the substances act like a conductor. At a low temperature, at a 0 K, the substances act like a bad conductor. In that sense, so that temperature increases, therefore the substances allows, and when temperature decreases, the substances does not allow. That is what we can call semiconductor. So there are three types based on the electrical properties. The substances are classified as three. One we can say conductor, and one more we can say bad conductor, and one more we can say semiconductor. That is what conductor, the substance which allows the flow of charges, and the bad conductor, the substance which does not allow the flow of charges, and semiconductor, the substance which allows partially flow of charges. See, bad conductor, in case of a bad conductor, the electrons are tightly bounded with the nucleus. In case of a conductor, in that conductor there are number of free electrons are available, so that electrons are responsible to conduct the conduction, that means to allow the charge. Semiconductor, that very simple, high temperature it act like a conductor, low temperature it act like a bad conductor. That is what we can say the substances are classified as like this. So this is the today's class. Thank you very much. We will see in the next class, and again continuation is there in this next topics. Thank you very much.